This morning, I want to welcome you into our class today that we are going to study Excitation Systems, and my name is Rogers Matinda. The outline of what we are going to look at today is, first we are going to look at the functions and performance requirements of an excitation system. Then number 2, elements of an excitation system. And number 3, types of excitation systems. For the functions and performance requirements of an excitation system, we are going to look at the functions. First, we look at the functions of an excitation system, which are 1. To provide direct current to the synchronous generator field winding, and number 2, to perform control and protective functions essential to satisfactory operation of the power system. Remember, there are two things: provide direct current to the synchronous generator field winding, and perform control and protective functions essential to satisfactory operation of the power systems. Then we are going to look at the performance requirements of an excitation system, and these are determined by 1. We do generator considerations, and on generator consideration, we check the supply and just field current as the generator output varies within its continuous capability. And number 2, respond to transient disturbances with field forcing consistent with the generator short-term capabilities. And these short-term capabilities are rotor insulation failure due to high field voltage, rotor heating due to high field current, stator heating due to high VAR loading, heating due to excess flux. Number B, we consider the power systems, and this contribute to effective control of system voltage and improvement of system stability. Okay. Then we look at the elements of an excitation system, and these include 1. Exciter. We have the exciter, which provides the DC power to the generator field winding, and we have the regulator, which processes and amplifies input control signals to a level and form appropriate for control of the exciter. Terminal voltage transducer and load compensator. This senses the generator terminal voltage, rectifies and filters it to DC quantity and compares with the reference. Load comp may be provided if desired to hold voltage at a remote point. Another element is the power system stabilizer. This provides additional input signal to the regulator to turn power system oscillations. Very important. And the next is the limiters and protective circuits. Ensure that the capability limits of exciter and generator are not exceeded. As you can check from the diagram there, we have the regulator, we have the exciter, the generator, we have the power system stabilizer from the block diagram. So you should be conversant with this block diagram. Next, we have the types of excitation systems. These are classified into 3 broad categories based on the excitation power source. The keyword here is the power source. And 1, we have the DC excitation systems, and 2, AC excitation systems, and lastly, we have the static excitation systems. 1, we start with the DC excitation systems. Under this utilizes the DC generators as source of power, and they are driven by a motor or the shaft of the main generator, and these generators can either be self-excited or separately excited generators. However, these excitation systems were phased out from 1920 up to 1960. They lost favor in the mid-1960 because of large size. They are very large because now as you can see, they are including the and the motor. Then number 2, we have the excitation systems. Here we use AC machines, the alternators now, as source of power. and usually the exciter is on the same shaft as the turbine generator. The AC output of the exciter is rectified by either controlled or non-controlled rectifiers. Rectifiers may be stationary or rotating. Early systems used a combination of magnetic and rotating amplifiers as regulators. Most new systems use electronic amplifier regulators, and when we talk of controlled, we use the thyristors, and non-controlled we are using the. Then we have the stationary rectifier system. In this system, the DC output to the main generator field is supplied through slip rings. When non-controlled rectifiers are used, the regulator controls the field of the AC exciter. Very true, very important. When the non-controlled rectifiers, where we are using the diodes now, is used, the regulator now controls the field of the exciter. So you should be able to note the difference between when the non-controlled rectifiers are used and when controlled rectifiers are used. Yes, because when the controlled rectifiers are used, the regulator directly controls the DC output voltage of the exciter. So that is the difference between the two. And as you can check from the diagram, you can be able to get the clear picture of what I mean. So those are the two diagrams for the field controlled alternator rectifier excitation system and alternator supplied through controlled rectifier excitation system. We have the rotating rectifier system. There is no need for slip rings and brushes. In other words, they are eliminated. Such as systems is called brushless excitation systems because it does not have the slip rings, it does not have the brushes. That is why we are calling it brushless excitation system. They were developed to avoid problems with the use of brushes perceived to exist when supplying the high field currents of the large generators. They do not allow direct measurement of generator field current or voltage. And that is the generator, that is the diagram, the block diagram of a brushless excitation system. So you need to master this diagram so that you can be able to answer questions in. Then lastly, we have the static excitation systems, and all the components are static and stationary. The supply DC current is directly to the field of the main generator through slip rings. Then the power supply to the rectifiers is from the main generator and the station auxiliary bus. So that is it. That is all for excitation systems. So students, I would like you to make some few notes about the excitation systems, static excitation system, and make sure that you draw that diagram. You can find these ones in the internet. So please, that is an assignment. Otherwise, thank you very much for listening to me. I wish you the best. See you next class. Thank you.